Just a few days ago, an unusual Tesla prototype was spotted rolling through the streets of the Bay Area, sending waves of speculation across the EV community. At first glance, some dismissed it as nothing more than a stripped-down, budget-friendly version of the Model Y, a crossover trimmed back for the mass market. But on closer inspection, with every curve measured and every camouflage seam analyzed, it became clear this was no Model Y at all. What we're looking at could very well be the first glimpse of Tesla's long-anticipated compact model, the so-called Model 2, a car designed to break price barriers and finally deliver the long-promised $25,000 Tesla. Today, we'll dive deep into why this isn't just another reshaped SUV, but instead a purpose-built hatchback engineered for efficiency, affordability, and practicality, with numbers, dimensions, and design cues that prove it. The silhouette alone begins to tell the story. Measuring 160 inches in length and 58 inches in height, the prototype undercuts the Model Y's proportions by a wide margin. That's a 27-inch reduction in overall length compared to the Y's 187 inches, and a clear move away from bulky crossover territory into the realm of compact city cars. This is not simply a case of Tesla shrinking down its vehicles, it aligns perfectly with the standards of compact hatchbacks like the Chevy Bolt EV, which sits at 163 inches. The width has also been trimmed to 68 inches, a full 8 inches less than the Model Y, which not only makes urban maneuvering easier but also lowers material use by an estimated 12% per vehicle. That kind of cost saving is no small feat. It represents either greater margins for Tesla or a potential pass-through to consumers, making the dream of an affordable EV more attainable. Even the roofline speaks volumes. Where the Model Y carries a gentle 28-degree slope, this prototype reveals a sharper 35-degree fastback profile. Beyond aesthetics, that change shortens the rear overhang and improves aerodynamics by an estimated 0.02 drag coefficient points, potentially stretching range by 8 to 10% on a modest 45 kWh battery. That could mean fewer charging stops and greater day-to-day usability. Beneath the surface, the wheelbase has been calibrated at around 100 inches, notably shorter than the Model 3's 113-inch spread, supporting a near-perfect 52-48 weight distribution. This kind of balance directly enhances stability and handling precision, pointing to a car that will be agile and enjoyable in tight city environments where larger EVs often feel cumbersome. Space efficiency continues the theme. While the cabin is smaller, about 93 cubic feet compared to the Model Y's 120, the packaging is smart, with up to 45 cubic feet of cargo space when the seats are folded flat. That's half again as much as some smaller subcompacts like the Fiat 500e, proof that Tesla isn't trading away practicality for affordability. Efficiency metrics suggest that with a projected drag coefficient around 0.25, the car could achieve more than 4 miles per kilowatt-hour. That translates to roughly 220 miles of EPA estimated range on the 45 kilowatt-hour pack, impressive numbers that put it ahead of many current competitors. For drivers, that means real-world benefits, easier parking, fewer charging stops, and lower energy bills month after month. The front of the prototype offers further evidence of this new design direction. The fascia features a slim 0.8-inch LED daytime running strip paired with compact 4-inch projector modules, smaller, simpler, and cheaper than the more elaborate lighting setups on Tesla's premium models. Yet, the signature Tesla look remains instantly recognizable. This choice signals a shift toward efficiency and cost reduction without losing the brand's visual identity. More importantly, the redesigned front end demonstrates Tesla's maturity as an automaker. Despite shrinking the crash structure to 26 to 28 inches, 10 inches less than the Model Y, engineering data suggests deformation resistance has actually improved by 20% in low-speed impacts thanks to clever integration with the battery frame. In other words, Tesla has managed to cut cost, reduce weight, and improve safety all at once. Weight savings up front are especially impactful. With approximately 150 pounds shaved off compared to the Model Y, the car could gain an extra 12 miles of range without altering the battery size. The headlights and fog light arrays also show thoughtful packaging, with a 2-inch auxiliary module cutting LED count by 40%, saving Tesla around $200 per unit. That's the kind of optimization that adds up when scaled to hundreds of thousands of vehicles. At the same time, the fog light design meets SAE standards with a 30% glare reduction, ensuring safety isn't compromised. Altogether, these front-end refinements suggest not a stripped-down budget car, but an intelligently optimized compact vehicle that prioritizes value and efficiency. Around the back, the camouflage can't hide everything. The rear tail lamps measure just 1.5 inches deep, running on simplified printed circuit boards that cut wiring complexity by 60% while still delivering higher visibility than regulatory standards require. Once again, Tesla is proving that simplicity can mean better performance. The hatch design reinforces this philosophy. Instead of a multi-piece assembly, the prototype shows a seamless one-piece hatch, which reduces welds by 15% and lowers assembly weight by around 25 pounds. Practical benefits include easier opening, requiring just 20 pounds of lift effort, and a wider loading area, making the car more convenient for daily life. For parents juggling kids and groceries, or city drivers hauling bikes or gear, this is exactly the kind of usability that matters. Cargo space itself underscores the hatchback orientation. With 15 cubic feet available in standard form and up to 35 cubic feet with seats folded, it hits right at the level of established hatchbacks like the Honda Civic. The flat 48-inch floor and 300-pound tie-down rating prove this isn't a token storage area but a practical space engineered for everyday needs. On top of that, structural reinforcements in the lower sill push torsional rigidity to 3,000 Nm per degree, 10% stronger than the Model Y. This extra stiffness also reduces noise and vibration levels, making for a quieter and more refined ride, something rarely achieved in smaller, affordable cars. When all these details are connected, the picture becomes clear. Tesla isn't merely trimming down its existing vehicles or experimenting with another concept shell. The evidence points toward a carefully engineered compact hatchback designed to break into the sub-$25,000 market without abandoning Tesla's trademark efficiency, style, or safety. The dimensions promise 12% material savings and up to a 10% range boost through aerodynamics. The front end achieves 40% LED cost reduction while actually improving low-speed crash protection. The rear design simplifies manufacturing by 15% while delivering greater structural strength. Each piece adds up to a car that feels less like a compromise and more like an evolution, tailored to real-world drivers who want affordability without losing innovation. For those of us following Tesla's journey, it's exciting to see the numbers tell a story bigger than the spy photos themselves. The Model 2, if that is indeed what we're seeing, isn't just another vehicle in the lineup. It's a carefully crafted response to the growing demand for efficient, affordable EVs that still feel like Teslas. This is the kind of vehicle that could redefine the entry-level EV market, making electric ownership practical for millions more people worldwide. And with prototypes already on the road, the wait for confirmation may not be much longer.